So if we look at these questions, using the method we've been using so far about bigger numerator and smaller denominator, that wouldn't quite work because, for example, if you look at number 7, in 3/4, there are fewer pieces, 3 pieces rather than 5 pieces. But the quarter is a bigger piece size than the 7th. Yeah, if you cut a whole bar into 4 pieces, each piece is bigger than if you cut a whole bar into 7 pieces. So there's fewer pieces, but each piece is bigger. And in 5/7, there are more pieces, but each piece is smaller. So which one's bigger and which one's smaller? It's really difficult to see. We're going to have a look at question 9 as an example next. Okay, you don't have to write this down just yet. Let's move to the example. Okay. Now here is the example question. If you want to write that down in your book, and we'll walk you through how this is done. And I'll be writing notes, and you should also write notes in your book. And if you ever think I'm going too fast, you can always pause or replay and then continue, okay? Now, if you were to draw the fraction bars for 2/3 and fraction bars for 3/4, if you have a tool or if you use your ruler, very accurately drawn those 2 fraction bars with each piece being the exact equal size within the bar, then you can see that 3/4 is bigger. But if suppose I'm going to draw like a 3/4 just by hand, 3/4, and then I'm going to draw my 2/3 by hand, not so well. Actually, it's not very clear whether I could get very accurate outcome by comparing the fraction bars. So that's really not the best way of dealing with how these questions work. Okay. So without an accurate fraction bar, what do we do then? Notice if we were able to sort of match these pieces up, then we can sort of compare them. So suppose if so what's that size over there, that extra bit? But look at, I could also, okay, hold on a second, delete this funny bit. If I cut it there, kind of, maybe further this way, just a little bit this way, okay? And then cut it there, well, quite evenly, as even as I could, alright? There. If I can cut this fraction like so, what have I made? What have I made these fractions into? On the top, what is that fraction actually represent? On the bottom, what does that yellow bar represent? Pause the video and write your answers down. When you finish, press play. Right, so if we recut these fraction bars into smaller pieces, we can actually sort of match up the number of shaded squares. On the top, the 3/4, the 2/3, the 2/3 has become, well, if I cut these things over here, what happens here, yeah? I still have to cut these ones, so because my fraction, each piece has to be the same size. So if you notice that, if you didn't notice that, your previous answer that you've written down might be a bit off. But if you notice this, you will notice I've made my 2/3 into a different fraction. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 12 pieces. And the shaded squares are 1, 2, 3, 4, 5, 6, 7, 8. So 8. And my 3/4 has become a fraction also with 12 pieces as in the denominator, and I have the yellow highlighted, let's say 9 pieces. So my 3/4 is bigger because each fraction is represented by something over 12. So our piece size is 1/12, and the first fraction's got 8 pieces, and the second fraction's got 9 pieces. Okay, so that's a generic way of comparing fractions by turning their denominator the same. Notice, what is this process going from 2/3 to 8/12? This is our equivalent fraction work that we've done before. Okay, so 2/3 is equivalent or in value same as 8/12. And how do we get there if we don't have a fraction bar? It's because we can multiply both the top and bottom by 4. What that means in a fraction bar is that instead of cutting the whole bar into 3 big pieces, we further cut each piece into 4 little squares. Yeah, so that's your 1, 2, 3, 4 for the first piece, first third, and 1, 2, 3, 4 for the second third, and 1, 2, 3, 4 for the third third. Okay, so originally it was in thirds. Now if I multiply the denominator by 4, I'm cutting the whole thing into 3 sets of 4s, which is 12. And then I am taking the two big pieces, but each big piece is 4 small pieces. So my numerator has to go 2 times 4, become 8 small pieces. Okay, so same thing goes for the fraction on the bottom. From 4 pieces, from the original 4 pieces, in order to become 12 pieces, I have to time the numerator and denominator, both denominator and numerator, by 3. Okay? So this is a general way of comparing fractions, and you should be pausing this video now and writing this example down in your book. In your next set of work, I would like you to write this type of working out for each pair of comparison. Okay, write a calculation. What are you multiplying the top and bottom by to get your new fraction? What are your new fractions? Which one is bigger as a result? Okay. When you finish writing this example in your book, press play again. Now, if you finish writing this in your book, that would be your example to continue the rest of the work. But notice, how do I know that I need to use the number 12 as my new denominator? That is the same denominator that I'm going to use for both numbers. How do I know it's going to be 12? Well, we need to find a common number that both 3 will times something into, and then 4 will times something into. And that is the concept of lowest common multiple. Okay? Because this number, if it's a multiple of 3 and a multiple of 4, then I know that 3 times something is going to be 12, and 4 times something else is going to be 12. And I can find this number to change my original fraction into its equivalent fraction. Okay, so LCM, the lowest common multiple, is a very important topic that you need to grasp before doing this work. All right. Now, let's have a look. I need to give you this work. But I need to delete these answers first. Ooh. Let's see. Oh, hang on. I'm supposed to cut this. Right. So I did flash you the answers just now. But no worries. If you don't peek back at the video before, this is your new set of questions. We have done question number 9, so you don't need to do that again. So we've done that one. In your book, you should attempt question 7, 8, and 10. When you should pause your video now and try to work these out yourself. Okay? And when you finish, press play again to check the answers. You ready? Okay, here's the answer. It's a bit lumped together. There we go. That's much better. Okay? So this is the final answer of the work that I've just shown on the screen. I haven't written out how you got from the original fraction to the new fractions. Okay, in your book, you should write those out as well. And when you finish all this work, I will upload some other comparing fractions for you to have a go. Right, bye for now.